done. No point waiting any further. So I'm going to record this, guys, and happy to redistribute should you want to go through it again. I don't think you'll need to. Hopefully, we'll be able to have more one-on-one sessions after this. But anyway, my name is Darren, and today I have the opportunity to go through a piece of work that's taken us about six months. To be honest, it's the most complex piece of work that I think we've ever done on the platform, to be honest. ASHRAE 90.1, Appendix G 2019, and this is the intro. Now, as I mentioned there, I have a name, I have a face. I've been working in the sustainable design industry for around 20 years. Lots of the time that I've spent has been in a consultancy capacity, focused on facade engineering, building physics optimization, and probably in about 2009 or something like that. That's when I first kind of picked up. I had a development pathway where I was very much focused on IES and Design Builder in the early days, and then I got into Energy Plus and eQuest and Open Studio, probably in about 2009, 2010, and started to learn a lot more about, I guess, software. And the platform that I'm going to be talking to you about very briefly today is, a result of all of that learning. Now, before I get into that, I'd love to know how to focus this session, because I've got a predetermined list of slides here that I can talk to. I assume that the education in the room about 90.1 Appendix G 2019 is pretty high. I can see that there's a bunch of names there. Can I just, if you have more than 3 years experience with 2019, can I get you to put your hand up, please? So more than 3 years experience, just show your hand there, raise a hand, just so I can see that, and I'll be able to focus on that. I might just turn this camera off as well. That allows me to focus a little bit more. That's great. So these are our super experienced people, and I can put names with that experience for sure, because I've read a lot of documentation around Energy Plus and 2019, so no surprise there. So what about 2 years experience? If you want to keep your hands up there. 2 years experience. Okay, it's a way of doing it, right? 4, great, thank you, Christina. Great. 5. Oh, 4. Oh, what's that? Is that number? Oh, that's the number of hands up there. What about a single year experience? Okay, cool. And put those hands down, and so I'll just get the folks just to play the game a little bit. If you have no experience at all, I'll get you to put your hand up now. If you've got no experience at all, and there's nothing wrong with that. This is what this session is about. Okay, so we do have a lot of experience in the room. There's a few people without much experience. Thank you very much. Thanks for playing the game, guys. Okay, so let's get into this. What I haven't done is I haven't blocked your videos or your ability to communicate with me in any way. I'm just going to ask you just to keep your mics off and videos off until the end, and then we can jump in and do some questions. Now, before I get into really a bit more about who we are, I just wanted to highlight SimBuild. So obviously SimBuild is coming to Minneapolis this year, and we're very much going to get behind it and support it, and certainly going to attend it as well. I'm hoping to get one of my papers accepted so I can do a 15-minute talk there. But yeah, if you haven't checked it out, go ahead and check out SimBuild, because it's a great opportunity to get into the room with like-minded people. And we sponsored the event in Brisbane, Australia there last year, and I think it's a really eye-opener for us in terms of this community. So we're a big fan of that. Now, I'm just going to quickly throw a timer on, because I tend to talk too much. So I've thrown that timer on. Let's get into it. A bit of background about Better Building. We started, about 7 years ago, and we've had a lot of fun ever since. developing up effectively products for the market. And we've had a lot of success as well locally in Australia and New Zealand. We position ourselves as a platform because we're in the cloud. Effectively, there's nothing downloadable. People jump on their teams, they share access, and can do lots of things all around the subject matter of environmental design. What do I mean by that? Well, pretty much you can jump in there, use Energy Plus on the back of this of our platform in order to undertake energy related calculations, and that could be thermal, could be emissions, it could be comfort. You can design advanced HVAC systems, and Energy Plus has been an incredible resource for us to both learn and apply on the platform. We've also got Radiance there, and that helps us obviously undertake daylight sims. We do some interesting work in moisture, going back to that 15 minutes that I'd like to kind of present at SimBuild this year. We've used Energy Plus to build out hydrothermal moisture calcs, and they correlate really, really well to WUFI, which is really cool. We do carbon. I've mentioned the advanced HVAC, we'll get into that. And we also do a bit on project management. We call it flows, but it is a way of effectively setting goals and timelines for projects and managing documentation, which is a part of effectively running energy, daylight, moisture, and carbon sims. So that's that. We've got loads of support on the platform. I'm not going to go into this, but there's lots of support in all facets of support, whether it's tickets or access to free on-demand courses, documentation. All our testing and verification is all on our document site. I'll pop in a link for all of this at the end. We've got a bunch of people using the platform. Some of these won't be familiar to you guys because these are very much Australian, New Zealand centric companies. A few of them would be KBR, maybe Oricon, maybe Condor. We've got hundreds of companies using the platform now. Anyway, that's a sales pitch over. We can now get into Appendix G. So 90.1 has been an interesting ride for us because the platform that we've built out over the last 7 years has been effectively structured to expand to undertake calculations for other markets. And what I mean by that is that we can then adopt new building codes very, very quickly. So we're very compliance centric, if you like, but we all know that compliance, hopefully we all know that compliance is a starting point to get past that minimum requirement and then hopefully exceed it down the line. But effectively, we saw Appendix G and we said, okay, is this the one for us from a 90.1 perspective? Because obviously there's a lot of stuff in 90.1. And we started looking around and we, just realized that, hey, it's complex. It's 400 pages plus in 90.1. But we said, okay, 2019 seems to be the right version of ASHRAE, and Appendix G is certainly not perfect. Nothing is from a code perspective, to be uber clear in our view of the world. But we thought, well, do you know what? While it is complex, it seems to be being picked up. And if we look at this, and I got a screenshot of this there the other day, it was last updated at the end of last year. And we can see the green there, the dark green, the darkest green is 2019 and 22. So really what we're looking at, we're going, okay, let's implement workflows, solutions for just these two versions of the code. I mean, there is an opportunity to go back to 2016. I'm going to ask for hands up there. How many of you think that an application or workflow would be useful for 2016 in addition to 2019 and 22? Obviously, we can go ahead and do that. We're focused on the future rather than the past, to be quite honest. But we have one hand up there from what I can see. Thank you very much. Really appreciate your feedback. We're focusing on 19 and 22 for the time being. And there are fundamental changes between those earlier versions of ASHRAE and 19 and beyond for the PRM. And I hear the PRM is not going to last that much longer anyway. But anyway, so we've got a good market, a good opportunity. There are other players out in the market doing this already, and they're doing it really well to one degree or another. I'm not going to start picking around the software, but effectively there are solutions out there everywhere from free to expensive. And the question probably might be to you, well, why bother doing this again? Well, we still see opportunity to improve, and I'm going to get into the narrative around why we see that opportunity to improve now in a second. As previously mentioned, Energy Plus is our foundation. On the back end of the platform at the moment, we have really an evolved solution whereby which we have a few different versions of Energy Plus, and we've just added on version 25.1, which is the only version that can be used with 2019 from our perspective, just because we've done all our testing on version 25.1. Elsewhere on the platform, you can jump in and use other versions of Energy Plus should you want to, but all of our testing has been done on 25.1. And just on that subject of testing, we have 4,000 to 5,000 tests now running on the platform constantly. So it's all in the cloud, as I mentioned, and it's imperative that we have the stability of those tests, and those tests are just going to increase in volume over time as we add more stuff onto the platform. But yeah, deep dive into 2019 tells you there's lots of stuff, and we're quite thankful for the opportunity to read the documentation with some sort of clearer narratives and different perspectives, and PNNL certainly have provided that. We always go back to the standard itself, but seeing other documentation out there on the market allows us a clearer read of it, or a supporting read, should I say, right? So we have the documentation already, but there's other fundamentals here. We also have resources from PNNL again, and we looked at these Open Studio standards, which is a Ruby gem library that extends the Open Studio SDK. And we thought, well, do you know what? This provides us with such a great launch pad into this discussion. We could go it alone and develop up everything ourselves, which is what we've done in previous versions of the code. Or different versions of different codes internationally, I should say. But this gave us a great opportunity. And if you haven't checked this out, please go ahead and check it out. It provides a complete rule set of PRM rules particularly for the baseline building, which is extremely complex from an international perspective, and a great launchpad into understanding effectively what's happening. Anyone can get access to this, and I think the only thing I can say is a big thank you to the team that exposed this, because it's allowed us to get I think a good foundation on parts of the process. This is not the whole process. We've had to build on top of this, but it's allowed us to directly use this to form a point of confidence in terms of Appendix G. Now, when it comes to Appendix G, we really want to look at what we refer to as the power of parallel compliance. And effectively, our real simplistic view of the world is this: when you're undertaking calculations for Appendix G, you've got geometry. You have the requirement to specify and simulate, and you have the requirement to verify and report. Yes, this is a very simplistic view, and it's intended to be. I'm going to dive deeper into this in a wee bit. But yeah, sure, we can do this, and this is what we have available on the platform today. So you can jump in and do this, and I'll talk about that in a lot more depth. I guess when I refer to the power of parallel compliance. What I'm referring to is that, because we've got the geometry and because we've got the ability to automate, we can also get into section 11, which is the energy cost budget, which arguably will be of greater interest because of some of the challenges around Appendix G 2019, but also other elements of the building envelope in section 5 too, and maybe other elements of ASHRAE altogether. So what we're looking at and what we're going to be deploying over the next couple of months are effectively Appendix G 2019, Section 11, or Energy Cost Budget 2019, and then we're going to go back and do it again for 2022 for both Appendix G and Section 11. So all of this is coming in the next couple of months, and then we'll see what we do with, I guess, Section 5. So there's a lot of workflows that are going to be deployed moving up to the effectively sim build this year. Now, when it comes to, I guess, our view of the world, and let's just put an imaginary timeline down there, this is kind of what we think a workflow looks like using our platform when we compare it to use cases overseas, and then we say, okay, this is how ASHRAE can be deployed in this very simple view of the world. The geometry takes 60%, the specification simulation only takes 20%, and the verification report only takes 20%. So whether you agree or not with that, that's kind of what the experience is on the platform at the moment. What it says is that the biggest effort is geometry, specification and simulation is easy, and as is verification and reporting. Now that may not be the truth for many folk, because we have, of course, the advent of folks just using AI to produce reports, and there is lots of this going on all over the place now. Not that we condone it ourselves; we produce reports directly. But if that was the case, then we might find our geometry is still 60, our specification simulations expands a bit, but our verification report even drops down more in terms of percentage of time. Now, in terms of how much time, I'm not sure how much time a typical practitioner would spend on delivering an ASHRAE 90.1 2019 PRM report and process. I'm not sure. I don't know what this is. I can only talk about what it would take for a typical project on the platform when I compare back to the experience of other markets. And for us, it's effectively a morning's work. Okay, so when I say a morning's work, I'm talking about geometry building, specification, and reporting. It's all done in a morning. So I don't know whether that's fast or not. I'm assuming it probably is. And it's effectively because there's so many opportunities to take in terms of automation and processing that we find it to be an extremely quick process. Now, even if I said that was a day's work, it's still a great opportunity to get stuff done very, very quickly. So there's a lot of process that is, I guess, embedded within those hours, whatever those hours tend to be. So let's talk about that a wee bit, and we'll just get into the process of effectively what a lot of you guys will know around what represents the ASHRAE 90.1 process. So when we go through the process, we obviously set up some geometry and specify that geometry. Then we've got the design day data. So there's a lot of opportunity to effectively automate and look at the sizing and look at the design load assumptions and automate that too. We have the unmet load hours. Of course, we have to go through that process for the proposed design in order to ensure that they are below 300. So all of these connections provide an opportunity. We've got to get the energy performance out of that and then get the performance cost index. All we see here is opportunity to improve this process, and that's where we see time savings, and that's where we see automation without the use of AI. Okay, so no AI involved here. Sorry for the AI fanboys and fangirls, but there's no AI being undertaken here. This is all just engineered processing in the background that allows improvements of what is, I think, the most complicated workflow for minimum compliance on the planet. Now, where the I guess the PNNL measure comes in that I mentioned earlier is the fact that the baseline is effectively automated in the process. We get the geometry specification and we create a baseline. We oversize based on the proposed design information. We then have our unmet hours. Of course, we're down below 300 again. And then we have to spin the building 4 times and get the average energy performance in order to get that second part of the equation for the performance cost index. So there's a lot going on here, but again, it can be processed pretty quickly. Now, I'm just going to talk to the performance cost index a little bit because ASHRAE 90.1 at the end of the day becomes an economic analysis. It uses obviously energy data, but it becomes an economic analysis where effectively you're just dividing that proposed building performance against the baseline building performance to get this performance cost index. Now, I always find I have to check myself when I look at this stuff because these terms are very, very confusing to me. The fact that performance is mentioned in proposed building performance and baseline building performance, that performance term should be cost. It's based on energy, yes. It's based on dollars at the end of the day. So I do get thrown by the use of this language here. But anyway, for those very new to this, think of the baseline building performance as the costs associated to meet minimum compliance. The proposed building's energy performance is your actual design and needs to perform better than that baseline. That's about it, right? And the building the performance cost index quantifies by how much. Now, I'll spend a few minutes going through this just for those folks that are really, really new to it. But to generate a performance cost index, we need to generate a target for the baseline building. So there's another equation here that we need to get into. And it's effectively this value here, the performance cost index target, which is what we're trying to improve on. Yeah, the formula looks a little bit intimidating at first. I'm dyslexic, so I kind of see all of this stuff all as the same thing. But I'll break it down. And by the way, this is automated on the platform, right? So you don't necessarily need to know all don't necessarily need to understand and take away from this exactly what's going on. Because we automate this and it's a part of the process that makes life that little bit easier on the platform. Not to say that you shouldn't try to understand it. Now, for the first part of this equation, we have the baseline building unregulated energy cost. It is kind of what it suggests it is. It's the annual cost associated from stuff that the standard ASHRAE 90.1 doesn't regulate. Process loads, effectively. They could be anything. Could be server rooms, kitchen equipment, etc. Specialized stuff in your building. This gets a free pass, I guess, because the standard can't dictate really how your business operates. So that's that part there. Next up is the performance factor, and I'm sure, and I know a lot of you know all about the performance factor. So the building performance factor is a climate zone building type specific value. To shortcut a question, you can override these values on the platform should you be working with LEED or needing to meet specific state requirements. A quick look at them. This is what the table looks like. I'm sure we've all seen this before. This is directly taken from 2019 and 90.1. And as you can see, there's specific values for different buildings and different climate locations, with the climate locations running along the top and the building types running down the side there. And should you be in climate zone 3C, you can see that this office building has a building performance factor of 0.48. If we were in climate zone 5B, the same building is going to have a building performance factor of 0.51. So this value is simply brought back into the equation, as you all know, and they have certainly represented challenges because they can be very onerous and difficult, a difficult component of the compliance pathway. Next up is the regulated energy costs here, and these are the energy costs from systems that the standard does care about. HVAC lighting, service hot water, building envelope performance, that stuff, the stuff that it controls. And then finally we have the building performance, the baseline building performance, and this is the total annual energy cost of your baseline building. This is your denominator, if you like, your point of comparison here. So there's like a very, very, very simple breakdown. Here's an example where the building unregulated, or the baseline building's unregulated energy cost is $10,000 there. The performance factor is 0.53. The regulated energy cost is 15K, and the baseline building performance in this case is 25K. This gives us a performance cost index target of 0.72. This is the bit that the baseline building that we need to beat, that we need to surpass. Okay, we need to be better than this value here. Now, we have a little simple equation here. And if we throw some numbers at it, let's say your building costs 19 grand a year to run, 25K was the baseline building, you can get your performance cost index out of that, and in this case it's going to be about 0.76. okay, so this is a higher value than the target that was mentioned earlier, about 0.72. So clearly we have a challenge. You know, you have opportunities in the solar space that if you want to get into that, you certainly can. This is all done on the platform as well, and effectively you can gain credit for renewable energy contribution from a cost point of view to a maximum threshold of 5%. So our interpretation of this is that this prevents, you know, buildings from being covered with solar, to avoid that kind of terrible buildings scenario whereby which people just overextend the solar in order to have a cheaper trade-off instead of improving their HVAC and their building envelope. So that's a little bit there just about the, I guess, the overall process. Now I'm going to get into the inputs now. So that's it. Equations done. 23 minutes in. So I'm going to fly through this and we're going to get into effectively our approach. Now, just before I do, what we are doing as a part of our deployment this year is that we're reaching out to get to convert models here. So we've been doing lots of work in conversions. Over the years, we've realized that, and as others have realized, that the GBXML conversion hasn't been as successful as we would like. So effectively, we've started direct conversion. So if you want to directly convert from eQuest to EPJSON, we can do that for you. If you want to convert from IES Design Builder to EPJSON, we can do that for you and drop it into your profile. We're also looking at conversions from directly from DXF and PNG PDF to effectively identify the outline of your building in order to extrude and provide an EPJSON that way. The EPJSON is just a way of interacting with Energy Plus, and is in our opinion, a much easier and cleaner process to get good geometry, such as the Opera House there on the screen. So reach out if you want us to help you with that. What it does, it allows us to test our processes over the next 6 months on the back end without exposing you to the nuance of conversions, which can be quite complex, and there's lots of scenarios that need to be handled. So if you do that, you get a model done for you. Please don't give us anything like the Opera House because it's too complex. give us something a little bit easier, and then we get the proof that we can actually develop it up and we can then deploy for you to use on the platform. Done. Now, when it comes to geometry, I'll take you to the platform just for a second because it's easier to tell that story over there. Let me see if I can find the platform there. There you go. Okay, cool. So this is just a design that was brought into the platform. It's an office building. It's a well-known design. You may have seen this before, but this is just I guess a proof of purchase. This came directly in from IES in this particular case, and it has everything that you'd expect to be able to nominate from a design point of view. This is our 3D viewer. So we have two viewers. I'm going to show you the 2D and the 3D processing. This is just our 3D, where effectively you bring this in, you then go ahead and seek or do a matching for the number of levels in the building. So you can go ahead here and we can go ahead and detect the number of levels in the building in order to be able to then go ahead and see all the zones within the building and the levels in the building. And then once we've got that, we have the ability to then effectively go to the geometry and say, hey, okay, I want to go ahead and specify all of those windows. I won't go into too much into the details of this, but you can go ahead and then specify all the walls. You don't need to do it in that fashion. You can go ahead and specify all the walls in certain zones or for certain levels. So it's extremely quick, and this is showing you or giving you an indication of where effectively the geometry processing is just very, very quick from our perspective. Now, when you're building out your geometry, you're building out for your walls, for your roofs, for your floors, for your windows, and you can have multiple types. We have a system called tagging that allows you to tag individual surfaces or multiple surfaces in order to distribute specific information to those surfaces. We have other abilities such as opening windows. Discard that one for a second. Make sure I've got this one here. You can bring in your F factors for your floors, etc. So it's kind of all there for you to nominate and do. For folks in the Energy Plus space, you'll see that those standard terms: external, adiabatic, ground contact. It's just showing you Energy Plus is under the hood, and just on that point of Energy Plus being under the hood, there it is there. So Energy Plus 25.1, as I mentioned, you get all. What? No, that's not true. I was going to say you get all the control that you can get in Energy Plus, but we have the ability to provide all that control, but we don't. We effectively provide the control that people need in inverted commas because we don't want an over explosion of inputs, and for anyone that wants more control, they just request it. And we provide that control, but obviously we then need to test the features. But effectively, we can expand to the full, I guess, capabilities of Energy Plus over time, and that's effectively what we've been doing. And on that case in point, I'm just going to show you the HVAC here. So from an HVAC perspective, let me clear that one for a second and bring in a template, and we can bring in multiple templates here, and this is very much a space that will be expanding. If I bring in something like a central plant and air handling system, and you can connect that up to multiple spaces, we'll go into that. Well, we won't go into too much detail there because we won't have time, but you can then go ahead and nominate specific information for all components of the system and do something equivalent to multiplexing across the building. If I just pick air handling unit as an example, go in, set all your system sizing, set point, everything that you would do in Energy Plus is all available here. So I won't talk about this too much longer because I've kept an eye on the time. What I'm going to do, I'm just going to flick back to the old presentation here, and I'll let you contact me to go through more details or send you information about this. So let's say you've got your building specified, you brought it in, you're good to go, everything's nominated. Then up in the top right hand corner here, you have what we call as workflows. At the moment, you can see the performance rating method up there in the top right hand corner. You can also see daylight, design, day shading impacts. These are all things that you can run at the same time. effectively what you'll see is that the energy cost budget method and the performance rating method will all be available up there, so you can run them both at exactly the same time. Today we have the performance rating method, and if you click that button, you start to get decisions around, or opportunity to make decisions around the performance rating method. So here it is. Here over on the left hand side, you can see we have multiple things that you can look at. So we have, first of all, we have building, then we have unmet hours, and then the performance cost index itself. So these are all things you can control, you can have make decisions about. Let's go into the easy stuff to start with, ASHRAE 169. So you can go ahead and nominate your climate zone. You need to do that anyway. Makes sense that you do it here. You can go ahead and nominate your service hot water as well, and whether your building is running multiple baselines or single baselines. Obviously we default to the multiple baselines, but should you want to have control over that for whatever reason, you can. Now, if we go to the next, the unmet hours, you can make a choice on whether the unmet hours are just for unmet hours of for the occupied unmet hours, or whether it's for the total. So you have control over that, should you want to make decisions around that. For us, we're still learning about general industry practice, so we are trying to provide here like the scope that we expect people to want to have a decision on, and we may remove some of these inputs over time as we learn more. In terms of the scope, we're only going to look at a single proposed design, and there's your cooling set points and heating set point tolerances, which are the correct defaults, as you can see here. So these are in metric, but this can be displayed in imperial as well. And then finally, you have the performance cost index. So here you have a toggle on. Are you using the performance cost index? If you are, great. You can then go ahead and nominate your building type, and then we will nominate the performance or the building performance factor for you, or you can go ahead and override this and use whatever building performance factor you like that is, I guess, nominated either through LEED or through other state requirements. Okay, so there's definitely an opportunity to get a lot of information out here. Now, once you've gone through that process, you're saying, okay, I want to run a simulation, and just pointing towards a couple of other things here that I haven't covered yet. Renewables, if you want to undertake renewables on the platform, you can go ahead and do that. When I say renewables, I really mean photovoltaics, and you can nominate those in order to get a potential benefit from them up to that maximum of 5% for your design. And you can also nominate a lot of different tariffs associated to your building performance cost index. So there is a deep dive here in terms of the tariffs available, and tariffs become very, very important for the performance cost index. So this is all available to quickly do on the platform, and everything here is open for feedback, right? We're not really saying that we've nailed this by any means. We're saying that, hey, this is our interpretation at this point in time of what is required by the market. And yeah, we've definitely found in the past that we've got these things wrong, but this is what we think needs to be considered by the market in order to undertake a meaningful approach to ASHRAE 90.1 Appendix G. Now, for those that were just wondering about what's actually under the hood, effectively we have AWS servers, and they're in Oregon for you guys. And effectively, all we do is batch process all of your jobs there. So the vast majority of PRM jobs will all be batch processed. because of the likelihood of the size of those processes. You may be able to undertake very small projects in your browser, but bear in mind that if there are multiple simulations going on here for the baseline building, and you need to be aware of that, or for both buildings, but you need to be aware of that, because it will exceed about 10 minutes in your browser. But when you're running on 32 cores, we can heavily optimize the process. So a building such as the building there, in the example, that comes back, I think that probably comes back around 4 minutes of simulation time for both the baseline building and the proposed design. So it's pretty fast. It's pretty fast. Now, what happens at the end? You get an email summary, and you click on that button, and then you can go into your results. So this is the important bit, the outputs, and a big part of this is substantiation and understanding that you've got things right. So let's say you've gone through the process, you've nominated your geometry, you've specified your HVAC systems, you've specified your building envelope, you've made a decision on what your inputs are from a performance rating method perspective. Now you're getting ready to run, and we are now effectively going through this process and running and looking at the results of your simulation. Up in the top right corner, we have the performance cost index. In the small text below, you have the 0.53, which happens to be the max, or the target in this case, and it's 0.36 is the result. So the green nominates, hey, that's a positive thing. And then you can see the summation of the unmet hours as well for both the proposed and the baseline. So it gets post-processed for you just like this. It's extremely tight in terms of what it aims to communicate, but you've got to go through a process of acceptance before you see these numbers, you get the green ticks, great, but is this all correct? Okay, so it's super important to make sure that substantiation is a part of your process. And here we provide a summary that justifies the numbers up there on the top right hand corner, and there's a lot of information there. And then we go into the actual equations of the performance cost index, so you can actually check these out directly yourself. And then we summarize the unmet hours. Okay, so that's all summarized for you, but that's only really the high level information. You can then dive down into your proposed building and your baseline building, and you can actually export all of this data and get the results from both proposed and baseline being the average here. So there's lots of information here for energy. And this is where we'd need to get into an actual demo to go through this in more detail. And I will be releasing training that explains all of this. So this is really just trying to provide a tight introduction. All information on zone loads, solar. You can look at the energy transfer at the walls, floors, roofs, windows, etc. You can look at your locations of unmet heating and cooling here. So there's lots of information. You can get a download of exactly what your HVAC system comprises, so you can be confident about effectively what's happening under the hood after you've nominated your HVAC system. This is all for the proposed design, by the way. You can see a big green blob, which is effectively your conditioned space, and that's the bit that we care about in the design. And then you can go ahead and verify whether your wall, floor, roof and window systems have the respective performance values that you expect them to have from a proposed design. And then of course dive into the site data, the climate data, and get a feel for all of this. Now there's lots of stuff here. I know there's lots of stuff, and I'm just running out of time, so I've flying through this a little bit quickly. You can get all your results in detail. So if you really want to dive into the detail, you can dive into the detail. And as I mentioned, you can export this as well directly, so you can open up natively in Energy Plus should you want to. And that provides you just with another level of confidence that things are correct on the platform. And if you want to get into the details, you can certainly get into the details and go ahead, and this is just a random set of details that are available for what is this for? This is for zone air size, air system sensible cooling energy. Cooling rates, yeah, that's just for a couple of zones. Anyway, it's just a level of detail that you can interrogate your model and make sure that things are correct. So I'm about running out of time, so I'm going to just pull up, take a breath, and give you the opportunity to, ask a question, jump in there. Sorry, turn your mic off, turn your camera on. I'd love to have a chat with your initial interpretations of the platform, and whether you see it as a benefit, or whether you see challenges with its application, um, or its potential application, I should say. So, what do you think, guys? Any opinions around what you've just seen? Have I been clear enough in terms of what we've delivered? Maybe a show of hands. Give me a little bit of confidence that I haven't been waffling too heavily. Not clear? Okay, that's okay. Thank you. A couple of people saying it's clear. Okay. Okay, thank you. Okay, cool. A few people. I'm just wondering whether others found it unclear in terms of what's happening. I mean, there is a lot going on here, so I'm not suggesting that this has been a perfect delivery, but it should be clear enough in terms of what we're doing. Would anyone like to kind of jump in and ask a question around any facet of 90.1 Appendix G 2019 that I may not have covered that you think is of industry importance? A few shy people in the house. Okay, I'm just going to just assume that I nailed it then. Okay, well, look, I can. Would anyone like me to jump onto the actual platform? Christina, I think there's a hand up by you. I'd love to hear from you. Um, yeah, what's have you got a question there? Have you got some thoughts? Um,
Oh yeah. Can you hear me?
I can indeed. Hey, how you doing?
Okay. Yeah, I'm just it looks really interesting.
Mm.
And I kind of got I kind of got hung up on your estimate of 4 hours to do this.
Yeah, 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 yeah. It's too
I'm
quick.
curious what that includes, because usually you have to do for an example, we use the pollination
Yeah,
workflow where we go right from Revit to the IMP for eQuest,
yeah,
but we
yeah,
still have to do cleanup, and that can take us 6 to 8 hours, just to do some cleanup in the files.
yeah.
So I imagine that you have some automation with going from BIM to BEM here, but usually there is cleanup required. So 4 hours, I got hung up on it because I can't I can't see how you could create a proposed model doing takeoffs and all that kind of stuff in
Mm.
4 hours. So if you could explain a little bit about that, it would be helpful.
Yeah, so look, I didn't actually mention Revit there, to be honest, Christina. I mentioned other cleaner workflows of effectively geometry that is built for purpose. So eQuest, IES, Design Builder, much cleaner workflows to come through than Revit. Revit is an absolute nightmare, and it's one of the workflows that I have looked at, and I know the guys in pollination have done a great job in what they're doing, but it's a very challenging job. So I was not focused on that, Christina. I was only focused on effectively going from a geometry that is fit for purpose for another energy modeling process. So it
I
was like
see.
it was like
So that
it
step
was
is
like
not there.
bem to bem. I guess it is.
Oh,
Like
okay. That
like
that's the disconnect, because
there you
usually,
go. There you go.
doing takeoffs or all that kind of stuff, like that takes time. It's hard to get around that.
Yeah.
So
Well,
you're saying you've already have the geometry built out in another tool, and you're coming into this. Okay, that helps a
yeah.
lot.
So
And thanks for the
there's
presentation too. Very well presented.
okay, cool. Look, thanks for that. One other thing that I'll just take an opportunity to kind of mention here as well is that, one of the things that we do on the platform as well is that you can kind of build things out really quickly as well, right? So, I only showed earlier the ability to kind of bring in a bring in or use a model from another process. But I honestly do not believe that Revit to BIM workflow after 20 years working in the industry is ever going to work as well as redrawing. I could redraw that building, this building in under an hour. Okay, this particular building I could draw it in probably 20 minutes, right? The building that I was showing there earlier, which was that other design, that's still only an hour of redrawing. Now I know no one wants to redraw, I get that bit, but at the end of the day, it's I think it's disingenuous to think that you can get a very clean workflow from Revit where Revit doesn't want to provide a clean workflow to you, and they're going to keep changing the ability to enable that export, because it's certainly not in their interest to provide it. So it's very difficult to maintain a conversion for that. And I think I'll keep tipping away at us in terms of trying to understand whether there will be an opportunity for that conversion. But I just don't believe it's true. And trust me, we built out, the GBXMLX importer, and we've got all of that, and we still see problems with GBXML. So I don't know. I'm not a believer, Christina, that you're ever going to effectively get a meaningful workflow. I would much rather just rebuild geometry, because it's so quick and easy to do. It's not difficult. But some folk will just don't want to do it.
Just to clarify, I wasn't trying to promote the Revit
No,
process.
I know. Oh,
I was just trying to say, like, we do have efficiencies in our process. Like, so you didn't think we were just manually doing it, from scratch.
Oh,
I
yeah,
wasn't
no, sure.
necessarily promoting it, but I was just saying,
no.
like, even with efficient practices, it still takes a chunk of time, was just my point.
Absolutely. And the only point I was trying to convey there is that I think there's just something a little bit disingenuous about being able to actually do that process effectively, continually, because there's just loads of market-based challenges that are involved with it. And, really building out something as brutally simple as this is it's just not difficult. So I just don't, after 20 years in the industry, and I know you've been around for a while as well, I just don't see the value of that process, because you still have to do so much cleaning up, and the cleaning up is far beyond the rebuild in terms of a time perspective. So when I go back to 4 hours, I'm looking at a Revit model, and I will just redraw that in an hour or two, and then the nomination of the specifications is not much work at all. Probably the understanding of the specifications is the work rather than the nomination of it, but it depends on the design team and how clear that information is. And then processing everything is really very, very, very little. So anyway, done deal. Thank you, Christina. I really appreciate that. Anything else there, guys? Looks great. Thank you so much for the presentation. I have got one question. How do you go about minimum fresh air requirements? Let's say for a VRF system. So I've got the model, or a model open here. If we go in here, so if you go into your spaces, I didn't talk about spaces, so that's my bad. But you can go in there and you have all the control that you'd expect to have for occupants, lighting, equipment, infiltration, ventilation. If you want to run airflow networks, you can run those, thermostat settings. I'm going to get to your point here in a second. Sizing and HVAC. So under the sizing, you have your outdoor air. You have a multitude of options in order to effectively supply that outdoor air. If you want to nominate a VRF system, pretty easy. Go in here, clear that. Select template, VRF with outside air, and then you can connect that to multiple spaces or just single spaces with multiple or single air handling units, and jump in and then kind of go ahead and start nominating over here. So there's lots of control. You have loads of control to effectively build out your system how you would expect to build it out. I know it's a bit of an odd interpretation of it, but you can, for those folks that understand, probably such as Jason on the back, how Energy Plus views HVAC systems, this is kind of how it's portrayed. But when we go into the results, we've got a lot more detail in the results. I don't have the results for this. Well, I don't have the results for this particular one, but I just wanted to cover one other point in terms of the HVAC side of things. Here is a bunch of results here, guys. They are run over the last few days, just some testing stuff. You can see here 2 minutes and 11 seconds for this particular model after it was batch processed. This is just retrieving the information now. If I go into the proposed design, go into the HVAC, there's lots of information here, but we can get into the HVAC schematic and go into the details of it and check out whether it's correct. Make sure everything is correct in here. So kind of a fluffy way to answer your question, but all the control is there that you need. Santiago, is it possible to import an IDF model? Yes, it is. Yeah, you can do that. No problem. I have the same question. Santosh, yeah, cool. We can do that. No problem. It's all just it's just a direct import. It's very, very easy. Making a geometry is like that of eQuest, right? Do we still need the DXF or is it direct to BB? So you can provide me with the INP file for eQuest and we'll just bring it in directly for you. That's easy. It's possible to extract the IDF. Yeah, absolutely. The extraction is pretty easy too. You can go ahead and extract it on the platform. Very easy done. What direct benefits does it gain from obtaining models from IES since they also cover? It's just really IES provides very, very clean geometry from a gem file perspective. So if you were to want to consider using the platform and you had IES models, that you could go through and do some verification work and make sure that effectively you're producing something similar. One thing I haven't mentioned, I'm not a very good salesperson, is that from a cost point of view, we are a fraction of the cost of IES. We charge monthly as well as annual, so we are a significantly cheaper platform, but we do a lot of what they do. I'm not saying we're as detailed orientated as IES. I'm not saying that at all because they've been around for a long, long time, but we do have plans that are effectively as cheap as what you can see on the screen. And if you're doing ASHRAE modeling, you're going to be either here or here, depending on the types of systems, HVAC systems, effectively, that are modeling and the size of the systems. That $199 per month, believe it or not, is up for 5 users. So we are extremely cost competitive in comparison to, the premium softwares out there. We don't do everything that they do, but we will be growing in our capacity to deliver something very, very similar from a detailed HVAC modeling over the course of this year, specifically because of our increasing need to model lead projects, green star projects, those types of things, which just necessitate a level of detail that will grow the platform over time. Now, anyway, sales pitch is done. Do you have a toll-free support if we have questions? In terms of questions, you can go into support. You have an embedded ticket system. We provide free courses. We provide access to our AI docs. You can book a workshop if you want, or you could raise a ticket. This is by far the best way to get us. You raise a ticket. You give us access to your design. You tell us what the issue is, what you've done to resolve that issue, and we jump onto it and get back to you. Normally between 1 and 3 days, subject to the plan that you're on. You can upload any files that you want us to look at, and we'll get back to you. So we service people very, very quickly. Normally, we service people on this side of the world within an hour or so. So that goes to the entire team, and whoever's available will pick up the ticket and respond to it. Do you have a toll? Oh, that's it. Done. Okay, guys. Well, listen, I've taken up too much of your time, but thank you very much for hanging around. I will leave it there. I've got another presentation to give on the other side of the US, so I will take a little bit of time out, grab another coffee. Maybe I don't need it the speed I'm speaking at now. And yeah, if you want to jump on, I'll send over the demo links and all that sort of stuff, and we can take it from there. Thanks a million, guys. Take care. Enjoy the rest of your day. I will leave it there, and I'll send over the recording as well. Thanks for the questions as well, guys. Good luck. Bye-bye.